Something called the two confusion principle. It says you should not be confused or uncertain about two things at the same time. So how this works in mathematics, computer science, these kind of algorithmic problem solving things is you have the problem you're working on and you have the technique that you're using to solve that problem. And in general, it's good if you're not uncertain about both of these things at the same time. So from a learning perspective, we want to start with things we absolutely feel comfortable about. And then we might build a technique that's new. And then once we feel comfortable with that technique, we can use it for a new problem that we're not comfortable with. But if we say, okay, we're going to use decision tree regression to predict housing prices in California, and we don't feel that we understand housing prices in California, and we don't understand decision tree regression, then it's really difficult to tell when we've made progress. So my principle for thinking about this is, let's begin with something that we can really concretely visualize. And maybe we can start with understanding decision tree regression by looking at classifying flower species. And the reason is that these are tangible things. We can actually see pictures of the flowers and pick up the flowers, and we can understand how we would solve the problem of the flowers. And then we can understand how a decision tree regressor would solve the problem of classifying the flowers. And then once we understand decision tree regression on that simple problem, then we go and we translate that knowledge to this new problem that we don't understand as well. It's difficult to develop that intuition if you're starting with a very complex thing that you're trying to analyze. So when we're first learning a technique, my suggestion is we learn a technique on something that's really simple.